Hey everybody, Mr. Mills here again. This is a data A video dealing with two things that are pretty important for what we're going to go into. First one, being able to multiply polynomials together. Some of them binomials, some of them with bigger ones. And then the reason why we want to be able to do that is the exact opposite, being able to pull them apart. And I talked a little bit in the last video with factoring. Factoring means being able to take something and pull it apart and make it smaller, kind of see what it's made up of. So today we're going to do a quick review on multiplying these polynomials together and what that looks like, and then how do we deconstruct them through factoring. I have several other factoring videos on my website, so if you want to go there at all to be able to look at them, that's totally okay too. So here we go. Hopefully this will help you guys spin this around for you. So we're going to start with this piece of paper right here, and we're going to look at multiplying these things together. So first off, when I have something outside of a set of parentheses, we use the thing called the distributive property to multiply those together. So I have to do the number to the number, so 2 times 3 would be 6. And then I have to do the letter to the letter. And x times an x is an x squared. And it is important that I signify the little 2 in the exponent spot to reference the fact that there is an x times an x right there. And then I simply distribute to the second part. 2 times negative 7 is negative 14. So there's my negative 14. And then x times, basically it's 1. There's like a 1 in there, so that's just an x. There's just a single x when I distribute it in. So 6x squared minus 14x, and that's what that looks like if I multiply those two things together. If I'm multiplying to a longer set of problems right here, I'm simply going to do the distributive property to each of the individual terms. And we know that there's separation by terms because of plus or minus signs in between them. So when I do it here, 4 times 2 is 8. A times a, we already knew that, that's a squared. Well, what if I have a b times a b squared? Well, basically I'm putting one b in with b and a b, so that's total of b times b, or b to the third power. Then I have to go to my next term, so 4 times 3 is 12, a squared again, and then that b just hangs out because there's not a b that goes in there. And it's not a 0, so I don't want the b's to just drop out. We just know that there's only one b when I multiply those two things together. And then the final thing, minus 16a, just a single a, right? And then b times b is b squared. So that would be an example of multiplying to a 3-term polynomial, or distributing all the way through it, okay? So our goal, again, is to be able to get into something called factoring. But I can't really get you into factoring until I make sure that you understand how this works. So what happens when I have a binomial, which is 2 terms, times another binomial, which is 2 terms? And maybe this will help, maybe it won't help. I'm not sure positive on this, but let's say that I had a rectangle that happens to be x minus 5 in length, and another, or width, whatever you want to call that. And the other one, the length, is 2x plus 3. So there's some unknown amount, and if I subtract 5 from it, I get this side. And that same amount, if I double it and add 3, I get this length. And I want to know what its area is. So if I want to know what the area of this rectangle is in terms of x, I would multiply these two things together, right? Length times width. That's a basic geometry formula. So how do I do that with these two expressions? Well, there's an acronym that we've used in prior classes called FOIL, which stands for multiply the first things together, the outside things together, the inside things together, and the last things together. And then that would be your result. So here we go, first things together. So that's first in each one of the parentheses, 2x times x is 2x squared. The outside things, so like if we do it like this, the outside things are the things that are furthest apart from the middle. That'd be a 2x and a negative 5. The inside things would be the two things right here in the middle, the 3 and the x. So outside. So here's the dealio. Most of the time, the O and the I can kind of go together. They can kind of hang out together. So if you have an OI, like in this situation, that can kind of go together, we're going to go ahead and put them together. So 2x times negative 5 is negative 10x. On the inside is 3x. And I'll go ahead and write them down for you right now. But know that those two things can be simplified together to get you more. And then that's F, that's O, that's I need L. So the last two things. Well, if this and this were the first two things in the parentheses, then this and this have to be the last two things. And I want to be clear on this. This negative sign goes with the 5. This positive sign goes with the 3. We have to look to the signs just to the left of the numbers. Like this x technically has an implied little positive sign, and that 2 has an implied little positive sign right there also. Okay? So then the last becomes 3 times negative 5, or negative 15. And then if I grab this and shove that together, the final answer is 2x squared minus 7x, because if I lose $10 and gain $3, I've lost 7 total. That's how those positive and negative numbers work together. And then minus 15. So that would be an expression for the multiplication of those two things. Then let's go over to this one. This one's a little bit more basic, and that's what we're going to lead into kind of on the next step. So x plus 6 times x minus 4. So if we do FOIL, and again, like I said, I have other videos that deal with factoring on my website. You can Google how to factor trinomials, stuff like that. They might help you on that too. But just keep watching. Hopefully this is all review. Hopefully. Whoosh, cross my fingers. First, x times x is x squared. Outside two things is a negative 4x. Inside two things is a positive 6x. Those two things are like terms, so that gives me a plus 2x. And then the last two things, I got a 6, positive 6, and a negative 4, so that gives me negative 24. So that is the product of those two binomials. Okay? So, one more time, this is all about multiplying and putting stuff together, but our goal, our end goal, and kind of why you talk about it's kind of like basketball. It doesn't do me any good to teach you anything about basketball if you can't dribble and you can't pass. So shooting only does us so much good if dribbling and pass is what gets us from one end to the other end. So we need some of the basic understanding of some of these things first. Okay, so you'll see that on this, there's no parentheses on any of this page right now. No sets of parentheses on any of this page. So I don't need to multiply any of this stuff together. What I want to do is I want to try and factor. And I want to make sure that we're clear on this. There are some basic rules to factoring. And the first one I like to talk about, this might sound a little weird. We're going to factoring like a dentist. So I know that dentists, maybe one of your parents is even a dentist too. Dentists do all kinds of work and good things, but what a lot of people know for dentists is dentists pull teeth out. Okay, so they want to take something and if it's bad or different, or maybe we're just moving it around for some braces, but they pull things out of your mouth, pull the teeth out of your mouth. So we're going to talk about here factoring like a dentist. And we're going to say, hey, if this is your mouth here, is there anything common to this and this that we can pull out? So on this first one, I would look at it and I go, I wonder if there's something that I can pull out. I can break it up into some stuff and multiply to it. So a 2 goes into a 4 and a 2, so I can pull out a 2. And an x goes into x squared into x, so I can pull out an x. So I can pull out a 2x, and we kind of did this at the end of that last video. And I know that I'm left with x plus 1. And you can see that this times this, and if you want to put that in parentheses, you can. You don't have to. But this times this does equal this. So I was able to factor this quadratic equation, quadratic because it's degree 2. I was able to factor this quadratic equation into 2 smaller parts. Okay. So this thing, this is a doozy. This is a lot of big stuff. So I'm going to factor it, even though it's like a degree 6. This is degree 5 because there's a 3 and a 2 and the letters are together. This is a degree 6 because it's a 4 and a 2 and those letters together. The numbers in front don't have anything to do with its degrees. Nothing. And this is a degree 4 because it's got a degree of 1 on the A and 3 on the B, so that's 4. Okay, so what can I pull out? So I'm going to look first at these numbers here. And I'm going to say, is there any number that goes evenly into 3, 6, and 12? Well, that's those greatest common factor. That's the GCF from before. So I can pull a 3 out. And then I look at A's. This has 3 A's, this has 2 A's, this has 1 A. So I know that there's at least an A common to each term. This has B squared. This has B to 4th, B cubed. So there's a B squared that's common to each term. So I actually have this right here, 3AB squared, which is the greatest common factor of this expression. So what do I have left over after I pull that out? Well, when I pull the 3 out of a 3, I don't get anything. I pull an A out of an A cubed, I get an A squared. I pull a B squared out of B squared, I get 1. So that's pretty much it. So I got A squared, that's what's left from this first term. And then divide 6 by 3 and I get a 2. I pulled an A out again, and there were 2 of them there, so that must mean there's 1 left. I pulled 2 B's out, and there were 4 of them originally, so there must be 2 left here. And then on this next one, in fact, you try it. Pause the video for just a second, see if you can write down what you think's going to go here, because that's pretty important that you can do that, what you think's going to go there. Give you a countdown, 3, 2, 1. So hopefully you put something like this for B, okay? Because if I multiply these back together, 3 times 4 is 12, that's good. A times nothing is still A, and B squared times B is B cubed. When I said nothing, I really meant like there's an implied little 1 in there for the A, but there's not another A because A times A would be A squared, okay? So what I've done is now I've factored these 2 things into 2 other things that are multiplied together. And that's what leads us into a huge part of this course and your ability to do this math and so many other things. Okay, and that is factoring trinomials. So all of these things are called trinomials. And I specifically picked these 4 because of what's going on with their signs in their terms. So there's 3 terms. There's a quadratic, what we call a linear, because it's just a single x, and a constant. Quadratic, linear, constant, quadratic, linear, constant, quadratic, linear, constant, quadratic, linear, constant. All 4 of these have 3 terms, a quadratic term, a linear term, and a constant term. Okay? And you can see on the signs, this one has a plus and a plus, this one has a minus and a plus, this one has a minus and a minus, and this one has a plus and then a minus. And those are the only 4 possibilities that there are with 3-term quadratics that have a degree 2, a linear, and a constant, okay? And it's how those things go together which allows us to be able to factor. So here we go. Factoring this, you know that I can't factor like a dentist, right? This first one was factoring like a dentist. You know I can't factor like a dentist, but I can see if I can get 2 things together that multiply this. Can't factor like a dentist because there's no, right, this has a 1, this has a 6 and an 8. The only thing that's common between 1, 6, and 8 is 1. And then all 3 of the terms don't have x's, so I can't pull an x out, okay? So what I can do is this. I can look for 2 numbers that multiply together to get x squared, and that's pretty easy. That's an x and an x. And those are going to go in the front portions of those problems, okay? Now, how does this work out? If you look back at this problem just a little while ago, we knew that x plus 6 times x minus 4 gave me this. Well, guess what? Here's how easy this is. This number right here, this last thing, you get from those 2 numbers. So I'm going to ask you real quick, how do you think you get a minus 24 from a negative 4 and a 6? And hopefully you said, dun, 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 yes, you multiply them. Okay, so you get the last term by the multiplication of those two numbers. Well, I wonder if there's any relationship here. Okay, so this one was from multiplication. Multiplication. How do I get this number? So, oh my gosh, look at that. I need a plus 2, and there's a plus 6 and a minus 4. So this number, this middle number, goes from the addition of those two numbers. And if you can keep that straight, we need this number to be a multiplication of these two numbers, and this number to be an addition of these two numbers. That's going to really help us with our ability to be able to factor. Okay, so here we go. Let's look at this again. See if I can break this down a little bit more. Okay, ready? So I need numbers that multiply together to get 8. So multiply together to get 8. Multiply to get 8. And add to get 6. Okay, so we did a bunch of factoring, right? So factors of 8. 1 and 8, 2 and 4. Do any of these things add together to get 6? You'd be like, yes! 2 and 4 do. So all you have to do is do x plus 2 and x plus 4. And if you watch, I know that these are right. I know that these are right because I'm going to multiply these back together and they're going to equal that. So first, x times x is x squared. Outside is 4x. Inside is 2x, so that's plus 6x. And then last, 2 times 4 is 8. And you can see that I ended up with my original things. But x plus 2 times x plus 4 is the result. Now, this is just going to freak you out, and I don't want to freak you out too much. I'm just going to kind of show you this right now. Here's my handy-dandy calculator. Okay, I'm going to go to my y equals. I'm going to clear out some of these big, scary graphs, and I'm going to show you something. And we'll deal with this later in class, because it'll be easier if I show you a bunch of this stuff in class with the calculator rather than doing it all in the video. So I got x squared plus 6x plus 8. Is that good? And I hit zoom 6. That gives me a standard viewing window. And you can see that that is absolutely a parabola, right? Awesome. So I'm going to go here. I'm going to go down to this next one. And I'm going to put parentheses in. And I'm going to do one of its factors. X plus 2 is one of its factors. So I'm going to put that in here. I'm going to go x plus 2. And you can see that when I graph that, that's definitely a line. And I'm going to put it in another one. I'm going to put its other factor, x plus 4, x plus 4, and close that off, and then go ahead and graph. And you can see that that's a line, but it's my belief that I take this line times this line, I multiply them together, it's actually going to turn it into a parabola. That a parabola is made up of the product means multiplication, the product of two lines. So watch this. I'm going to go ahead and delete it here. Clear that all out. I'm going to go up here. I'm going to put parentheses, x plus 4. And you can do this with me if you want. And then I'm going to go all the way over here to the left. Watch my cursor. Watch my cursor. See how it's all the way over here to the left? And it's blinking up and down on that thing. I'm going to hit enter once. And you can see that it's thicker, which means it's going to now graph that expression thicker, whatever that looks like. Now watch when I hit graph. This is my original parabola, and now you can see, watch, the thicker one lies right on top of it. So it tells me graphically and algebraically that those two things are the same and that these are factors of this. Okay? So I'm gonna speed through these ones a little bit right now, and hopefully this will work for you. I'm not going to take each one and do it the same amount of time as what I just did. So I got x squared minus 7x plus 12. So I know that x and x have to be in here. Factors of 12 are 1 and 12 and 2 and 6 and 3 and 4. Now, this is what's different than over here. Over here, both of those signs were positive, right? And it really doesn't have to do with this one, but this sign was positive. If I'm multiplying two numbers together to get a positive number, then they both have to be the same sign. They both either have to be positive or they both have to be negative. Everybody agree with me? So 2 times 4 is 8, and negative 2 times negative 4 is also 8. But I couldn't use negative 2 and negative 4 because I needed them add together to positive 6. Now over here, I know that 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. Everybody good with that? However, negative 1 times negative 12 is 12, negative 2 times negative 6 is 12, and negative 3 times negative 4 is 12. So it could be positives or negatives for each one of these things. I see that my middle term has to be negative, so that means both of my signs must be negative. Now I need numbers that add together equal negative 7. So 1 and 12, or negative 1 and negative 12 equal negative 13. That's not negative 7. Negative 2 and negative 6 equal negative 8. That's not negative 7, but negative 3 and negative 4 do add up to negative 7. So I get x minus 3 and x minus 4. If you were to take your graphing calculator out and graph that quadratic, x squared minus 7x plus 12, and in the next line put x minus 3 times x minus 4, you would see that those two things equal each other. Okay? Down here, remember, plus plus, minus plus. Those were the two situations there. Both of these have negative signs in the end, and the only way you can multiply two numbers together and get a negative is if one of them's positive and one of them's negative. Okay? So here we go. X and x. Factors of 28 are 1 and 28, 2 and 14, and 4 and 7. Good deal? So on this, I'm going to look and see which one might work here. So I know that this is negative, right? So that means one of these numbers has to be positive and one of them has to be negative. So I'll put a positive here and a negative here. And now I need them to add together to get 4. Well, if it's negative 1 and 28, that's a difference of 27. That's not 4. 2 and 14 is a difference of 12. That's not 4. And 4 and 7 is a difference of 3. That's not 4. So it could be that these things are not factorable. It doesn't mean that they have to all work. They're not going to all work. Okay? This one's not factorable at all. But you look at this and you go, ooh, but it could be close to 4. What if that was a 3? Then that would work out. So yes, x squared minus 3x minus 28 is factorable, and it does factor. Let me show you again here. 1 and 28, 2 and 14, 4 and 7, those are all the factors of 28. Because they're one of each sign, again, because one's positive and one's negative, and the reason one has to be positive and negative is because they multiply together to get a negative number, I need a difference of 3. So that's a difference of 27, difference of 12, that's a difference of 3. Now here's the key. I can't just randomly put the 4 and the 7 in these places. This has to be a negative 3 when I add them together. So if when I add them together it's got to equal negative 3, it must be the 7 with a negative and the 4 with a positive. And you can check those again, plug them into your calculator, and it will work out to get this. Okay, last one on factoring trinomials right here. So here we go. X and x. Because this is a negative, I have one that's plus and one that's minus. Factors of 35 are 1 and 35, and 5 and 7. And look, 5 and 7 differ by 2. Yay! So that means the 7, because it's a positive 2, the 7 has to go with the positive thing. And I get x plus 7 times x minus 5. Final one, I'll go ahead and do this multiplication for you again, make sure it works out. X times x is x squared. Outside two things, negative 5x. Inside two things, positive 7x. That's positive 2x. And 7 times negative 5 is negative 35. And you can see that that and that are equal. Okay. So, in conclusion with this, we started off in this video on taking two things and multiplying them together, or taking one term and multiplying it to 3 different terms and bringing that all up. And we did that because I want to make sure you make the connection between doing the exact opposite, being able to break stuff apart. And it's our ability to be able to factor which is going to play a role in so many other things that we do in this math class. So hopefully you took good notes on this. Again, I'll get you some problems for you to try. Good deal. We'll talk to you next time. Bye.